All right, happy 4th of, May the 4th of May be with you. Hope you guys had a great weekend. Continue to have great days there at home. Just remember this quarantine stuff is supposed to be coming close to the end before too long here. So we will hopefully continue to get out, get on out of this. Hope everybody's remained safe and everything. Remember, if you have to contact me, my phone number is 704-363-9034. Call, text, email me. Remember, if you put comments or whatever on assignments, I mean, I'm not seeing that stuff on day to day. So if you need to ask me a question or anything, please call me or text me or something. Good morning, good afternoon, good evening, whenever you may be. Once again, it's 8th grade science live from the Brennan bunker, or should I say my meditation chamber, deep inside the Death Star. But no, I hope, once again, everybody's having a great day. And here we go, talking about chemical water properties once again. So the last time we talked about the physical and biological characteristics of what good water is, but today we're going to talk about I can identify the chemical characteristics of water qualities. Remember that water quality is a description of the chemical, physical, and biological characteristics of water. So water quality can be given as good or poor, it can be polluted or clean, but whatever the qualification given, the factors that go into it remain the same. So today we're going to talk about those chemical factors. Chemical characteristics or chemical factors of water quality. The chemical characteristics we're going to be talking about are levels of dissolved oxygen and other gases, the pH level, the level of nitrates, and salinity. So first of all, we're going to talk about dissolved oxygen. Dissolved oxygen, commonly referred to as DO, is oxygen that is dissolved into the water. We talked about how dissolved gases, get into water when we talked about, the dissolved gases in the oceans. So basically, it's just when the air is in contact with the water and the water surface is agitated, you will have the transfer of gaseous molecules into the water and become captured and become dissolved molecules. They refer to it as diffusion, but I mean it's which is the crossing over of a membrane, which would be the surface of the water of a gas. But anyway, so these gaseous molecules do enter the water. So DO is the measure of the amount of oxygen in the water that is available. Available is a key word there, because there can be oxygen in the water that is not available. It's bonded to something else. Frankly, water is oxygen bonded to hydrogen. So it is chemically available for reactions and use by aquatic organisms. In the aquatic ecosystem, the DO balance is important for the survival of certain microorganisms and higher organisms such as zooplankton and fish. So normally, oxygen in water gets there through diffusion with the air and as a waste product of photosynthesis by aquatic plants. Just like we get oxygen from plants above ground, you get oxygen from plants in the water as well. So part of the formula and for how much depends on how many plants are operating in the water. So DO in the water in the surface water is used by all forms of aquatic life. Therefore, is measured to assess the health of lakes and streams. Dissolved oxygen levels in water vary with the seasons and actually varies over the 24-hour day-night cycle. So if you guys got to, again, remember, I mean, when things are awake and moving around, they use more oxygen, fish-wise and stuff, than they do at night when they're asleep and being passive. So obviously, the dissolved oxygen levels are going to decrease during the day while everything's using it, in some aspects, but, when the sun's out and plants are doing photosynthesis, they'll be producing more oxygen into the pushing it into the water as a byproduct. So I mean it varies over the course of 24 hours. When dissolved oxygen levels in a body of water decline, sensitive animals may move away, or they weaken, or they can up all the way up and die. High dissolved oxygen levels in potable. Remember, potable means you can drink it. Make it taste better. So the higher the levels of dissolved oxygen in potable water, the better it tastes. Well, imagine that. Good water, high dissolved oxygen, tastes better. Okay, funny how nature does those things sometimes. So the next thing we're going to talk about is pH. pH is the measure of how acidic or basic water is. So the pH scale runs from 0 to 14. Neutral is on the pH scale is 7. So values of less than 7 are acidic, the more than 7 are basic. So things that could burn you. So I mean, everybody knows about an acid. It's like, oh, I got an acid burn. Acids can burn you. Bases can do the same thing. Who here has messed around with bleach? When you talk about, Clorox bleach, that goes into your washing machine. That's not even a really high concentration of bleach, but that's what we get. So if you touch straight bleach, your fingers feel kind of slimy. Well, that's the basic solution of the bleach literally starting to eat your skin away and produce that slimy feeling. So you can get a burn from a base just as easily as you can get from an acid. So the further you get from 7, either way, going up the scale or down the scale, the more likely you are to be hazardous to you, to the point where it will tear up the skin, and it gets to the point where acids and bases both that you will destroy other things as well. It'll eat clothes. If you put bleach straight on, high potency bleach straight on something, it'll eat right through a piece of cloth, to the point where, remember, I used to wash aircraft. One of the things we had to watch out for was that our soaps had to be very neutral in their pH. Otherwise, you would have the soaps attacking the metals of the aircraft and causing corrosion. So acids and bases can get serious enough to the point where they will literally eat through metals as well. So obviously, if you've got a water where a lake or something that is very acidic or very basic, it's not going to be very hospitable to things trying to live in it or drink it. So acidic refers to the concentration of positive hydrogen ions. An ion is an atom or molecule with a net electric charge, positive charge, due to the loss or the gain of one or more. Typically it's the loss of an electron so that it becomes positive. A positive hydrogen ion is simply the nucleus of the hydrogen atom without any ions. So it's like, here's the nucleus of the atom. There's no electrons floating around, so it is a positive ion usually written by H+. Then you have a basic. Basic refers to the concentration of negative hydroxide ions. Hydroxide ion is this thing right here, which is a oxygen atom with one hydrogen atom. So if it had another bubble here and looked like Mickey Mouse, it would be water. It would be H2O. Well, this is OH, and it has a negative charge because it's got an extra electron compared to what the positive charges of the nucleus are. So it has a OH minus charge. And so both OH minus and H plus are usually found in water. It's a normal occurrence. As long as they're balanced, the pH is basically close to 7, where it's supposed to be. It's when you get too much of one or too much of the other, that you get a acidic or a basic water chemistry. pH of the surface bed, has a lot to do with its health. It has synergistic effects that impact the levels of other materials in water, such as iron, aluminum, ammonia, and mercury. So, for example, if water is acidic when it comes into contact with certain chemicals and metals, it changes them into forms that are more poisonous than they would be otherwise. It also has an effect on water treatment process. They have to know what the pH of the water is in order to use the correct process of chemicals to clean it up. So pH, plays not only, again, into what happens to things that get into the water. If the water is acidic or basic, it'll react with things that wouldn't normally react if the water was neutral. And you have to know what it is when you go through any kind of treatment process in order to be able to know how to clean it up. All right, so the next thing we're going to talk about, nitrates and phosphorus. So nitrates and phosphorus are things that are typically found in fertilizers. And what are a lot of fertilizers? Guess what? Poop. So poop from animals is always got nitrates and phosphorus, phosphorus kind of stuff in it. Whether it's bird poop, whether it's cow poop, whether it's pig poop, all these things are high in these two chemicals, nitrates and phosphorus. Nitrates and phosphates that are derived from them are chemicals that pose possible health risks to humans if their presence in drinking water is not controlled. If you get too much in the way of nitrates or phosphorus or phosphate, you will get algae blooms, because again, those things are basically fertilizers. And so plants love fertilizer. So you dump a bunch of this stuff into the water, all the plant things that are in there, specifically algae, will take off and grow out of control because you have all this fertilizer, which is, helping it grow and reproduce and divide and make more. Well, then they soak up all the carbon dioxide in the water in their processes, and they will change the chemistry of the water for the negative. And a lot of times you'll get they literally will cover the surface of the water, and you can't do anything. They literally will cover the entire surface of water, and they'll start interfering with the ability of gas molecules to cross the water air membrane, and they will block out the sunlight from things that are below them. So plants that are below them will perish, and then suddenly you'll use up all the carbon dioxide that are in the water for the plants, and the plants will all die, and then suddenly there's an oxygen debt, and you'll end up with fish dying as well. So typically it's anytime you get a surge in these things, it is a horrible for water. Typical major sources of nitrates in surface water include runoff, contaminant fertilizers, septic tank leakage, sewage and erosion, and natural deposits. Phosphates, on the other hand, are usually enter the waterways from human and animal waste. Well, that's what sewage and septic tanks are, right? Laundry, cleaning, industrial effluent. So laundry soaps typically have phosphates in them. Used to anyway. They're trying to get that stuff out of a lot of them because, again, every time you do your laundry, that water has to go through a treatment plant and get taken out of it before you can put that water back into the lakes where you got it out of. Industrial effluents, basically just the byproducts of industrial processes, create phosphates, which if you just dump them in the water, create bad water conditions. So we're talking again. So today we talked about dissolved oxygen in the water. We talked about the pH, how acidic or basic the water is, and we talked about how much nitrates and phosphorus are in there, basically in the forms of coming from runoff. And when that water runs off, it picks up whatever's on the land, whether it's manure that somebody spread as fertilizer, or pelletized fertilizer that actually somebody spread, or leaks from things that contains animal or human feces. So it's nitrates and phosphorus typically come from runoff sources, whereas a couple times you get industrial effluents, which is point source, but most of the time it's wide, it's just runoff from the land, farm fields, pig waste lagoons, chicken waste lagoons, those kind of things here in North Carolina. But they all produce poor water quality down the road. All right, so end of the lesson for today. Hope everybody's once again, make sure you like the video, make sure you subscribe to the channel, make sure you put a comment in the end saying, hey, I was here and watched this thing. Remember my phone number, 704-363-9034. Text me if you have any questions or anything. You can pretty much text me almost any given point. I will answer it. I've answered texts as late as 10 o'clock at night. I wouldn't call me that late, but office hours 10 to 4 every day. Please feel free to call at any time in there. If you do call or text and you don't get me, I may be doing something else, but please, if I don't respond to you within a day, please call or text again. 704-363-9034. Make sure you have that, kept it, plug it in your phone, keep it somewhere. And just, again, if you have questions, please reach out to me. I'll be happy to answer them. All right, so have a safe rest of the day. Count down the days where you can go see some people, right? This thing is nearly over as far as the quarantine side of things, that we won't go back to school for this year. But once again, we'll catch you all on the flip side.